On the screen we currently see the system that we use in geography of how to study a geographical issue. This is the system that underlines most of the Key Stage 3 and the Key Stage 4 course. So we're looking at what is the issue, what are the causes of the issue, what are the short and long term impacts, the positive and the negative of this issue, and also how is the issue managed. So once the issue happens, what do people do about it, how do they mitigate it, and how might the issue develop in the future. So predicting that, maybe looking at other case studies. We're going to look at the Haiti earthquake in particular. So this is the example, the case study we're going to use for the GCSE course in 2014 and 2015. We've got the cause of the earthquake. We've got an image coming up here, and the image shows us the North American plate, it shows us the South American plate, and it also shows us whereabouts Haiti is. There's different types of plate boundaries shown by different colours, but the one near to Haiti is a transform fault. So that transform fault means that the plates are moving in different directions. That puts stresses onto the plates, and also means that pressure builds up and energy is then released. There's lots of different types of faults in this area. So we've got convergent, we've got divergent, and we've got an unidentified or undefined fault. So people are not quite sure where it is, but there's evidence that there's a fault there. We're going to look at how to record and how to measure earthquakes. So looking at the magnitude of the earthquake. A term that's often used is the Richter scale, and the Richter scale talks about the strength of the earthquake or the amount of energy that's released in an earthquake. The Richter scale is something that was developed in the 1930s, so it's quite an old scale, and it was originally developed by Mr. Richter to sort out and try to identify the depth and the strength of the earthquakes in a specific region in California. More recently, a scale called the Macaulay scale has been developed, and this looks at the impacts of the earthquake. Whilst there's quite a good correlation between these two, there are some specific differences. So let's have a look at the Richter scale. We can see that the Richter scale, there's lots and lots of earthquakes below about 2, and these, you wouldn't really feel them. Up to about 3 or 4, there's lots of these, even in the UK. Again, some of these we might feel, and sometimes they hit the news, maybe some chimney pots fall off houses, so a real light impact upon the environment. Most recently, in 2011, we had the Japan tsunami. So the tsunami was around about magnitude 9. Now, even though the numbers go from 2 up to 10, there's quite a difference between each number. Between each number, it's a logarithmic scale. So that means between 2 and 3, the earthquakes are 10 times the size. And between 3 and 4, again, 10 times the size. So if we extrapolate that upwards, we've got between 2 and 4, it would be 100 times the size. In terms of the Macaulay scale, this is the impact of the earthquake as felt by people. Towards the top of the Macaulay scale, it's mainly how do people feel the earthquakes. So there might be slight vibrations at the lower end, maybe some objects in the house start to move around. And then towards the second half of the Macaulay scale, we've got what actually happens to structures, what happens to buildings. On this slide here, we've got some information about, on the left, the Macaulay scale, and on the right, the Richter scale. There is generally a correlation between the Macaulay scale and the Richter scale, so the stronger the earthquake, the greater impacts there are. However, there are some countries where the earthquake is not as strong, but there are more impacts, and vice versa, so there is a very strong earthquake in some countries and small impacts. There's many reasons for this. Maybe the buildings are built differently, maybe the land has got different elasticity, maybe there's different emergency procedures in this area. There are many impacts of earthquakes. So firstly we have ground shaking, and there's 2 types of waves. So there's the P waves. The P waves come first on the seismograph, and these are the compressional waves. So they move forwards, and you can see here at various points these areas are compressed. Then we have the S waves. Now the S waves are the waves where the earth moves up and down, and there's an amplitude to the wave and there's a wavelength. In terms of how this looks on a seismograph, this is what we would see. First we see the P waves, then we see the S waves. And on a seismograph there's different ways of measuring the impact or the measurement of the earthquake. So we've got the horizontal east to west movement, horizontal north to south movement, and also the vertical movement, the up and down movement. Some of the impacts of an earthquake. One is liquefaction. As the ground vibrates, the soil particles or the particles within the ground and the moisture, it makes the ground act like a liquid, so that, as we can see at the top in the image, we see that buildings start to sink into the ground, and maybe cars start to sink into the ground, as essentially the ground, because of the movement, becomes a liquid. We've got landslides. In Haiti there were some landslides, and these were exacerbated by the deforestation in the area, because it's quite a low income country. There's an LADC, there's quite a high pressure upon the natural environment, the trees and the logs, and these are taken away for fuel and for building materials. Some of the impacts upon people. It's not clear exactly how many people died in the Haiti earthquake, but it's estimated that over 220,000 people died. Of course, in that there's injuries, there was an increase in crime, a lot of prisoners escaped from prison, and their jobs and families also. So many children were left orphaned. Many of the images that we see from the Haiti earthquake are quite familiar, so there's an impact upon buildings. So the buildings that we see in the image here, we can see they may be quite rigid, may be built out of quite rigid materials, so they'll break and crumble easily. One of the classic images of the Haiti earthquake is the presidential palace in Port-au-Prince, so we can see the before and the after image here. And another one here that we've got is the differences between 2009 in December and January 2010. So at the top we've got quite a devastating impact of the earthquake here. At the bottom, this starts to impact on how people can manage the earthquake. So we have the United Nations headquarters in Haiti in 2010, so it's a before and an after, and you can see that the afterwards, it just collapses like a pack of cards and the building has collapsed, which also impacts upon how the area is able to manage the earthquake. One of the infrastructure things that has affected Haiti is the dockside, the bridges and so on. So initially any aid that was coming into the country, that was not possible because the deliveries, the cranes weren't able to unload the ships, the trucks weren't able to get around the country and so on. So the infrastructure had been damaged, and also the communications, telephone networks. As it is, Haiti is quite a poor country, and we can see that about 38% of people work in agriculture and about 50% of people work in services. So that dependence upon agriculture has been massively affected by the earthquake, and the services, so forth. There's different ways to manage the earthquake. Short-term management strategies, long-term management strategies. The short-term, the immediacy of the earthquake is about food, water and health, and those are the pictures that often people see on the TV because they're immediate, they happen straight away. After this we have the long-term management strategies, so it's about sustainability, growth, helping get the country back onto its feet. So how do people prepare for earthquakes? It's very difficult to prepare for earthquakes because no one knows when it's going to happen, but through study, through scientific activity and monitoring earthquakes, there's quite a good understanding about where earthquakes will happen. So areas such as Japan, New Zealand, the west coast of the United States of America have a good idea about where earthquakes are going to happen. So because of that, more developed countries will be able to develop better buildings, they're able to withstand earthquakes and move with the shaking, and also the schools will be able to educate students about how to deal with earthquakes, what to do in the aftermath, and also suggestions about emergency earthquake kits. In the future, for Haiti, we don't see a lot of Haiti on the news nowadays, but it's difficult to imagine that people's lives are much better than they were, say, 5 years ago in the earthquake. Many people are still in squatter settlements, many people are still in temporary relief camps, and cholera has spread throughout Haiti, and it's been the second biggest impact on the health in that area. So we get, what are the future developments going to be in the area? We'll wait and see what those are.